So let's go. I think that the best way for us to learn how SocketBox works is to actually see it in action. So we've got a tiny little live demo that we're going to work on this morning. And it's basically just going to be a click counter, like the hello world of UI design. And but the state is going to live on the server, and it's going to keep that state in sync with the clients using WebSockets. So this is extremely trivial, but I hope you'll be able to see how easy it is to get WebSockets integrated into your application. And then maybe this will give you some ideas that you could build off of. So let's look at an overview first. We're going to start with installing and configuring SocketBox. Then we'll look at the websocket.bx. We'll kind of cover some of the lifecycle hooks. We'll implement that as a live demo for a shared click counter. And then after that, after we've completed the live demo, then we'll come back and we'll talk about how you can solve some of the harder problems like authentication, routing, exchanges, and clustering. All right, so getting started. This is as simple as box install SocketBox. This is going to create the modules directory in your folder, and it's going to include SocketBox and all of its stuff. SocketBox has 0 dependencies. So if you install it, you're only installing the SocketBox code itself. And I haven't gone through and counted, but when I've been looking through some of the source code, I think there's probably fewer than 10 files or something like that. It's really small. So you're not adding a ton of weight to your application by doing this. But once it's installed, that's where we need to start configuring things. There's going to be configuration that happens both in your server.json file and your WebSocket file. Now you'll remember that at the beginning of this webinar, I said that one of the hard requirements was that you have to have your application running inside of a command box environment, right? And that's because part of the way that this is implemented is actually changes that were made to the command box server to recognize WebSocket requests and then pass them along to the ColdFusion application through the servlet interface. And so without that being there, SocketBox isn't going to be invoked within your application. So we basically have to enable that for the command box server and then configure the WebSocket BX file. Okay. So let's look at what a super basic server JSON is for WebSockets. I'm sure that many of you guys are familiar with command box. And so you know that there's a lot that can go into your server JSON to make it exactly what you want for your application. But I've stripped all that out so we can really just focus on what's necessary for running SocketBox on Boxlang. And you can see that it's pretty minimal, right? We basically just say, hey, we want to use Boxlang, and hey, we want to use WebSockets. So let's kind of step through this. The web block includes a lot of different configuration like HTTP bindings, things like that. But there's a new key called WebSocket, and that's the one that we really care about for this demo. And there's really only 2 configurations that we need here. One, setting enable to true. This is going to tell the server to recognize WebSocket connections and pass them on. George, I think that this is available on 6 and above, but I'm not sure if it requires a specific point version. That's a good question, though. I'll have to look into that. But if you're on a recent version of command box, you've got access to it. And then, okay, so we need to set enable to true, and then we need to set our listener, and we're going to set it to websocket.bx, right? That's kind of the convention that we're going to use for this. All right. And like I said, this is available in ColdFusion as well. So the WebSocket CFC is actually the default configuration if you haven't set it for Boxlang or something. Okay, so let's look at what it takes to create your WebSocket BX. This is a pretty simple file. There is more configuration beyond this that we'll talk about once we get to the Stomp implementation. But for now, this is really all you need to get up and running. So you create your websocket.bx, and then we're going to extend modules, SocketBox models, WebSocket core. And this is just reaching into the SocketBox library and extending that main WebSocket configuration file. And then we're going to implement 3 functions, right? The first one is onConnect, and this is just going to it's kind of like a listener. This is going to get called when the client connects. We've got onClose, which is going to get called when a WebSocket disconnects. And then we've got onMessage, which is going to be called for any message sent from the client to the server. Now, a couple things that I want to kind of call out here. You can see that all of these, that onConnect and onClose are both calling broadcast message, and they're sending a string value, and there is no channel specified. So when you invoke broadcast message, that's actually going to send data to every single connected client. Down here in onMessage, you can see that we're using send message. We've got our string value, and then we're sending it to a specific channel. So this allows you to target a specific WebSocket and send information to just that person. So what you might want to do is on Connect, you might want to store that channel somewhere, associate it like maybe in a map or something like that, and associate it with a user ID. That way, when you have data to send to a specific user, you can get out their channel or channels, because they could end up with a WebSocket connection maybe for every tab, loop through them, and then send a specific message just to that WebSocket. And then I'll also draw attention to this onMessage handler. You can see we're checking to see what the content of the message variable is. This is so that we could support multiple commands. So that might be something like, you might come up with your own little protocol here where you have message equals hello, do this thing, message equals user underscore list, send back the list of users who are connected, things like that. You can write whatever you want here. It looks like Scott has a question about, can this support other clients rather than just a JavaScript web client? And the answer is yes. It can support anything that can run a WebSocket connection. It can connect to SocketBox as a client. And actually, in fact, we'll talk about this a little bit later when we get to load balancing, but when you have multiple nodes in a cluster, all running SocketBox, and you want them to be able to communicate with one another, they can actually use WebSockets to talk to one another and help keep their state in sync, which is pretty cool. All right, so let's keep going. Covered onConnect, we covered onClose, we covered onMessage. So let's see what's next. Okay, so now we're getting into our actual demo. I'm going to show you a couple snippets of code here, and then I'll bring VS Code over and we can actually see things running. And I'll show you the actual application. But I like to show it this way because it helps highlight how little code is necessary to actually get this up and running. So this snippet right here is technically all you need on the client side to be able to connect to WebSockets and actually update your application live. You can see there's a script block where this new WebSocket, this is not a SocketBox thing. This is built into browsers. So all modern browsers are going to supply this WebSocket object that you can instantiate. Once you've got your socket, then you can give it an onOpen listener, and then you can give it an onMessage listener, where you will be able to inspect the event object and get the data out of it. You can see that this is almost very similar to how the websocket.bx file is implemented, just with some slightly different syntax. And then here we can get access to the socket and we can send the click event, which will go to the WebSocket thing. All right, so that covers the client side. Let's take a look at the server side now. So this is the implementation of the websocket.bx file for the click counter application I'm about to show you. You can see that it is, and actually I've made a few changes to the live demo, which I'll go over once I open that up. But you can see we've got our onConnect and onMessage functions where we're handling the state of things and broadcasting a message out to all of the clients. And this is super easy to implement. You'll also notice that there's no onClose function handler because we just don't need it in this circumstance. And so you can omit it without any problems. All right, so let's check it out. So here I've got this little click demo project that I'm working on. So I've got this little click demo project, and you can see that my project is right here, and I've only got a few files. I've got a completely empty application BX. This is just so that it has an application to work with. I've got my box JSON, which was automatically generated for me when I did the box install SocketBox. I've got my index.html, which is a poorly formatted, we make that even a little bit bigger, which is a very poorly formatted HTML file. You can see here that I did the absolute bare minimum. There's no HTML element, there's no body tag, there's nothing like that. Obviously, those things would probably improve the file, but this just shows you how bare bones you can get. And this is copy and pasted from that slide that I showed you earlier. We've got our server.json, and this is basically the same, except I've added the JVM configuration to make sure that we're on the JDK21. And now let's look at our WebSocket.bx. So here we've got our WebSocket.bx, and this is everything that we need for the functionality that I'm about to show you. We're basically just, when someone gets connected, we send them a message, which gives them the current state of our counter. And then every time we get a message for click, then we're going to increase that counter and broadcast it out to every connected WebSocket. And so that goes for WebSockets that are from multiple from different users, but it also goes for like if just one person connects across multiple tabs, each tab will get a WebSocket connection. I've already got my server running in the background. So I'm going to go ahead and open that up and we can take a look at it. All right, so here we go. I've got 2 tabs, both open to my Boxling server that's running. And you can see that they, if I refresh, they connect and they immediately show count equals 2. Now, it's not 0 because I was messing around with it before the webinar, just to make sure for the 100th time that things were going to work the way that I wanted. And I left it with a state of 2. So that's why it's already initialized. But what you'll be able to see is that if I go over here to this one and I hit click me, you're going to see this counter update, but you're also going to see this counter update, right? That's the magic of WebSockets. So if I click on this, boom. And if I click on this, they're both updating. So very cool, very impressive, very fast. And you can see that that was like, I don't know, I want to say even with all of the boilerplate and configuration, that was maybe like 50 lines of code to be able to add that to your application. I think that is a really cool achievement. Now, I do want to kind of call out for a second just some design considerations that you need to make when you're thinking about incorporating a WebSockets into your application, because you'll notice that there was a shift from in our code. The count variable really lives on the server, not in the JavaScript application. And so there are some subtle shifts that you need to make in terms of like architecture when your data is going to be living on the server. This is where it's really important to make sure that you understand the challenges of working in a load balanced environment with this. In this example, it's really simple because I've got one server, right? And so all of my WebSocket connections are going to be on the same server. But let's say that I had 3 servers running in a cluster. Well, if I opened this tab and I connected to server A, right? And then I opened this tab and I connected to server B, but my counter variable is being stored in the application scope. Well, that means that server B's count is going to go up when I do this, and server A's count won't, because those are technically 2 different applications, even though they're running in a cluster together. That's a totally solvable problem. And as I mentioned earlier, that's something that SocketBox has done a great job of solving. So we'll cover some of those strategies there. But I just want to help. If you haven't worked with WebSockets before, that kind of challenge can come a little bit as a surprise. But it really makes sense when you think about it. You know, this is the same type of issue that we run into when we are moving to sessions in a load balanced environment, right? If you have a single server that has sessions, everything's great. But then as soon as you start adding more servers to your cluster, you're going to end up in a situation where one server has your session and another one doesn't. And, you know, in this day and age, we have a million different solutions to that problem. We've got sticky sessions, we have database backed sessions, we have Redis backed sessions. And so that is going to be basically the same. Those style of solutions are going to be the same solutions that we have available to us in SocketBox for solving these problems.